Today in Algebra 2, we're going to look at using properties of exponents. In the first example, we have a to the m times a to the n. Okay, our base number here is a. As long as you have the same base number, you will keep the base and add the exponents. Okay, so an example of that would be like 5 to the third times 5 to the second. Okay, we have the same base number, so you keep the base and you add the exponents. 3 plus 2 is 5. Where when we multiply, we add exponents, then when we would expect to see that when we divide, we would subtract. So we can say that we have the same base, a and a, base of a to the m minus n. Okay, so again, we'll use a base of 5 to the third over a base of 5 to the second. So we're going to keep the same base because you have the same base, and then you subtract your exponents. 3 minus 2 is 1. Okay, when you have a base of a and it's raised to an exponent and that whole thing is raised to another exponent, then you multiply those exponents, a to the m times n. So if you have a base of 5 and it's raised to the third and that whole thing is raised to the second, then you keep your base of 5 and you multiply those exponents. 3 times 2 is 6. And the reason that you do that is because this 2 means we're going to do 5 to the third 2 times. 5 to the third times 5 to the third. So your base is 5, and then here are your exponents. You add them to get the 6. When you have two base numbers, a and b, and you have that quantity is raised to the m, then that exponent has to be distributed to each entity inside that set of parentheses. So you would have a to the m times b to the m. An example of that might be 5x, and that is raised to the third. That means that you would have to raise 5 to the third as well as x to the third. On the next example, a to the 0, any number to the 0 power equals 1, unless it's 0 itself. So if you have 256x to the 14th, and that whole thing is raised to the 0, it doesn't matter. That is an answer of 1. When you have a negative exponent, all that does is flip it into the denominator if it's in the numerator, and the numerator into the numerator if it's in the denominator. So a to the negative 1 would just be 1 over a. Okay, let's do an example of that. If you have 5 to the negative 2, that would just mean that you would put 1 over 5 squared. Or if you had 1 over 5 to the negative 3, to get rid of the negative, you would move the 5 to the numerator and keep the exponent of 3. You would just lose the negative. And so you would have 125. Let's take a look at these two examples. The first example, negative 4 times 2 to the 5th raised to the second. Well, remember that this exponent must go to the negative 4 as well as to the 2. So you will have negative 4 to the second times 2 to the 5th, also to the second. Negative 4 squared would give you 16 times 2 to the 10th, because 5 raised to the second power, that would be 2 to the 10th. So when you multiply that out, you would get 16,384. Remember, you can put that straight in your calculator and get that answer as well. Okay, our second example, 11 to the 5th over 11 to the 8th raised to the negative 1. This negative applies to the numerator as well as to the denominator. So it would send the 11 to the 5th to the denominator and 11 to the 8th to the numerator. They would just switch spots. Now it has the same base, which is 11, and then you would subtract your exponents. 8 minus 5 is 3, and that would be your final answer. On this example, b to the negative 4th times b to the 6th times b to the 7th. The base is the same in every single term here. So we're going to keep that base of b, and we will add those exponents together. Negative 4 plus 6 is 2, plus 7 is 9. So your final answer here is just b to the 9th. The second example, r to the negative 2 over s to the third raised to the negative 3. Okay, well, this negative 3 has to be distributed to each entity here in the numerator as well as into the denominator. So you have r to the negative 2 raised to the negative 3, so you're going to multiply those exponents together. Negative 2 times negative 3 would give you a positive 6 over s to the third raised to the negative 3 would be negative 9. Well, it's not proper to leave a negative exponent, so we need to clean this up a little bit more. R to the 6th is fine where it is. And to get rid of the negative exponent on the s, to get rid of that negative 9, we're going to move the s to the numerator, get rid of the negative, and leave it to the 9th. And that would be your final answer. The third example here, we're going to clean this up a little bit. We're going to start with our constants. 16 over 2 reduces to 8 over 1. Now we're going to look at the variables in order of the alphabet. Let's look at our m to the 4th. Are there any other m's anywhere? No, so we keep that right there where it is. Now we have n to the negative 5th over n to the negative 5th. Anything over itself is 1, so that reduces, and 8m to the 4th is your final answer. This is the final example that we will look at. X to the negative 2, y cubed. That quantity is raised to the third, so let's clean that up first. This exponent of 3 needs to be distributed to each one of these exponents here. So that would give us x to the negative. The assignment for Chapter 5, Section 1 will be 3 through 42, the multiples of 3. We will also need to do 50, 55, and 56. Y'all have a great day.